So the other day I went to get this. I went to get this cant hook out of here, and what happened was there was a big clump of ice in there, and I couldn't get the hook out. So somebody had said to drill a hole in here, and I know that that's a good idea, so I'm doing that now. See, there's some ice in there yet, so I'm gonna have to drill it a little higher yet. I have to put some salt in there or something to thaw that out. Looks like the water's pretty high in there. I think I'll get some salt and put it in there. But at least the weep holes are in so that it does drain once it thaws. I was asked a couple of questions about the saw blades and the effects of when you hit a nail and stuff. And I'm going to show you what I found the problem to be, and I don't think it's what you would expect. It's a little different. First of all, this blade here that I have in my hand here, if you look, you can see the shiny teeth there because I sharpened that blade. So this is the blade that had hit the nail yesterday, and I've already got it sharpened up. But what I want to show you is, if you look there close, you can see that these teeth here, this one and this one, have a sharp point on it, and this one's broken off here. Now, I could have ground that into a tooth. I didn't, because I want to see what happens when you don't grind them into teeth. I have ground a couple into teeth. Now, there's about 4 teeth on this entire blade that look like this. Okay, it's just got a broken tip off of it. Yeah, so anyway, the teeth break off when you hit something that causes the blade to react. Now, if you notice, I didn't say that the tip breaks off when you hit something. I'm saying it breaks off from a reaction, and here's what it is. If you look here closely, you'll see that it's obvious that the tooth has hit this guide that's on here. Okay, this is the guide for the throat size, and the tooth has also hit, there's some wear marks down in here on the chute for the sawdust guide, you know, to guide the sawdust out. Now here's the thing, and you have to realize this in either milliseconds or, you know, slow motion, but what happens here is when the saw hits something, the blade tends to slow down. But because the saw is tight on the wheels and everything, this side, like if you hit something like a nail over here, and this is where you do the cutting, this side of the blade actually wants to bend or weave. It's, for you old timers, if you've ever used a timing light on a car and you've shined a timing light on the fan belt when you give the throttle, you'll see that the belt expands and pulls in a different way at the rear side or the front side of pulleys, actually. Now what's happening here is this blade's going that direction, and because it hits something, this blade is forcing this stuff to go that way. So it tends to get a weave in it, and it also actually becomes loose enough to drop down there, and that's about a ½ inch, and hit this guide. And if the opposite happens, if the wood twists or something while you're cutting maybe a narrow board, the blade also twists and it hits this guide at times. So when it hits the guide, I noticed that when I go to sharpen, if the tooth isn't broke like this one, what you'll actually find is a curled piece of this metal on the tooth. I have seen this already and pulled those pieces off. Now, when the tooth gets hooked hard enough onto that guide, it breaks off. These teeth are heat treated, so it makes them kind of hard. I think they're called double hardened, if I'm not mistaken. But either way, the hardness of them also makes them slightly brittle. Now, let me put my glove on. They made a good blade by figuring out just the right amount of hardness. And then the teeth don't break off because you're hitting wood. The teeth break off because you're hitting metal, okay? Like here. So the blade's go in that direction, and it hits this, and some of the tips break off. Now, like I say, that's not the only tip on this particular blade, and that's the blade that hit the nail yesterday. So the blade actually cut right through the nail. It's the same thing. I have an aluminum piece that I use on the dogs, and I actually split it right down the middle, and the blade cuts through that stuff, and it'll cut through a nail. Now, I don't know about a railroad spike, but it'll cut through like a 10 or 12 penny nail. The problem isn't that so much. It's when the blade is bogged down and the motor's still running full, and it's wanting to push the blade into the cut, and it actually relieves itself of the tension. It actually it expands, and the blade will actually touch this guide down here. And when it touches the guide, that's when it picks up metal or breaks off. So that seems to be the problem with this. Now, it's not like a problem because of any kind of design or anything. It's a problem because when you hit something, the blade naturally wants to slow down, and the blade that's behind it wants to push, so you get a little bit of a bend in that. You don't see it. It's very hard to pick up, but I know that that's what happens to them. One of these days I'll put a timing light on this thing somehow and show you how that works. But regardless, that's what's been happening to the blades that I've experienced so far. The wood itself doesn't screw the blade up. It is, you know, either the blade gets put into compression while it's going through a cut because it's not set right, or it slows down because it hits something very hard, and that causes the blade to slightly warp, and when it does, it catches onto the metal. And that's how it breaks these tips off. Now, I'd say there's about 3 tips broken off on this entire 12-foot blade. So I don't think it's really going to affect the cut much. Now, I don't like the idea of not making a tooth on this. I think there should be a tooth on it so it's not getting a free ride running through the cut. But I'm going to try this blade because I want to see if it makes a difference whether you sharpen those blades to a point or not. Because no matter what happens here now, this blade is going to be lower than the other 2 points because it's broken off. So when I go to shape that, I actually have to come down into the gullet a little to get enough metal up there to make that cut. But it doesn't have to be as big a tooth as what you see there. You know, I can make the tooth smaller. But anyway, that's what I've noticed happens. And when it hits the metal, that's when you hear all the noise, when the blade is hitting these guides. It's not because it's hitting the nail. Now, don't get me wrong, you do hear some noise when you hit the nail, and I've noticed that some of you guys can pick it up on the camera. I can't pick it up yet. I'm not knowing what to listen for exactly. So as soon as I figure that part out, I'll take care of that, and then I'll let you know. But yeah, I sharpened this blade, like I said. This blade is the blade from yesterday that I hit the nail with. I sharpened it, but I did not sharpen the parts where the teeth were broken off, because I want to see how it's going to cut. But that's what I've experienced with these blades, and that's what seems to happen. The nice thing about hand filing it is when you take the time to hand file, you actually find all these imperfections, and then you can figure out what's going on with them. So then one of the other comments that I had seen asked about the way to adjust the Woodmizer saw, if it could tell how thick you were cutting. And it does tell how thick you're cutting. If you look on here, there's a scale there. Okay, this is in inches. And if you crank, you can see there's a guide. If you crank this all the way to the bottom, there's a crank here. It stops at the 1 inch mark. You can see there. And that's as low as it'll cut, a 1 inch off the bunk. So once you know that, these numbers over here refer to the bunk. All you need to do is, like say you have a log and you're at 12 inches and you want to cut a 2 inch piece, all you do is go down to 10 inches. I mean, it's that simple. Or you can go down to fractions if you want 5/4 cut on the saw or whatever you want to cut. And I'm not going to get into how much you should save, you know, for planing purposes. That's up to the individual. But I'm just saying that that's how you would use that. Now, as far as how quickly you can do it, what's nice about this crank, and it tells you right on here, 1 full turn, I'll go upside down with that, 1 full turn equals 2 inches, a half a turn 1 inch, and 1 notch is a 1/16. So when you turn this, you squeeze on this handle right here, squeeze the handle, and when you go 1 notch, that's a 1/16 of an inch, up or down. This direction here is up, that direction is down. Okay, if you're here, and usually you're going to work, if you're working full inches, you'll be working from this long line or this long line. All you need to do is just crank a half a turn, and that's 1 inch. If you want 2 inches, it's 1 full turn, and you put it in the same notch that has that big line on it. So it's very easy to work as far as getting the boards right. The only thing I would say is you have to try to remember, you know, you can use this ruler here to tell you how many boards you're going to get out of a cut, because these numbers are always the number off the bunk. So in other words, it's 6 inches off the bunk, 7 inches, 8 inches off the bunk. That's what you're talking about there. So sometimes in my videos you'll hear me tell my grandson, you know, go 6 inches off the bunk, and he knows to read that scale right here. Otherwise, I may say take a 2-inch board, which means that when you adjust the blade to be at the top of the log, you may want to come down 2 inches. The top of the blade may or may not be on an even inch mark. I found out that it's best to cut on even inch marks so you don't get screwed up in the end with a 3/4 inch piece or a 1/2 inch piece that you can't use when you're trying to cut, you know, full 1 inch boards. So the best thing to do is just work with the 1 inch marks in my case, and you can do this any way you want to, but that's how I figure it out, and it works really nice for me. So I hope that answers your question as far as how you figure out where you're at with the blade. So again, the blade always goes down to the 1 inch mark. That's the smallest piece you can cut, and then you just configure from the bunk where you want to cut. So if the top of the log is at 12 inches and you want to cut a 2-inch piece out of it, you just go down 2 inches. And like I say, the crank on the handle here, 1/2 a turn is 1 inch, a full turn all the way around to its current position, or any position that you're at the time, equals a full inch. 1 full turn equals 2 inches, a 1/2 a turn equals 1 inch. So, and each notch, like I said, is 1/16 of an inch, and it tells you that right on the machine. It's not hard to use. It's very easy to use. What you want to do then is, like say when you're cutting a cant, if the top of the saw, if the top of the log, let's say the top of the log is 12.5 inches off the bunk, the top of the round log, what you may want to do is figure, okay, I'm going to go down to 10 inches. That'll be like a 2-inch cut, 2.5 inch cut. And then once you get to that 10-inch mark, you can figure out accordingly with inches how far you need to go. So I always try to get to the nearest inch, you know, wherever that might be, or just make the board be an inch so that I can work with it. I'll try and next time I do some cutting, I'll try and make the video a little more explicit about what I'm doing with the controls over here.